The International Space Station is one of the most ambitious engineering and scientific collaborations ever attempted. Launched into orbit in 1998, it has become a home to astronauts. Almost immediately after it was habitated, the ISS was used to study the impact of microgravity on several aspects of our daily lives. Over the past 9 years, more than 400 experiments have been done regarding purification, muscular dystrophy, cancer treatment delivery, and vaccine development aboard the ISS. The accurate mass measurements of small organic and inorganic bodies is essential to each one of these experiments. The absence of gravity poses an interesting scenario for scientists. In space, both an orange and a football will float in midair, even though it is apparent that a football has more mass than an orange. Therefore, astronauts cannot rely on the gravitational force of an object to determine its mass. Instead, astronauts employ Newton's second law of motion to calculate the object's inertial mass, or the object's resistance to being accelerated by a force. Devices such as the Space Linear Acceleration Mass Measurement Device, otherwise known as SLAM-D, utilize the potential energy of a spring and Newton's second law to calculate the mass of a crew member between 90 and 240 pounds. Other devices aboard the ISS utilize the changes in frequency of vibrational motion to measure the added mass of an astronaut to the system. While these devices allow astronauts to measure their own mass, there is no equipment for the astronauts to accurately and easily measure the masses of smaller organisms. This is especially a problem in the case of mice, where the vibrational methods are too disturbing, and methods implementing Newton's second law require the mice to be sedated. Regardless, the measurement of these small masses is critical in the research conducted aboard the ISS.
Introducing Balance Space, a gentle balance designed to accurately weigh small organisms in microgravity. Balance Space will be able to provide the data needed to advance space research to new levels. Balance Space employs the idea that when more mass is added around the center of a rotating object, it spins slower. This is a corollary of the law of conservation of momentum. Balance Space consists of a small cylinder rotating around the center axis of a spinning disk. This disk is given an initial velocity through a low-powered motor. It is then calibrated by measuring that velocity through the use of a photo gate. Once an object of unknown mass is secured in the cylinder, the disk spins slower, and the slower velocity is measured. The velocities and mass of the cylinder are used to calculate the mass of the object inside using a simple program.
NASA has a plan to send humans deeper into space than ever before. The space station is one of the first steps. Balanced Space will help in measuring small masses and therefore accelerate the scientific discovery aboard the space station, preparing astronauts for the journey beyond.